Hi, everybody. My name is Francesca Rossi. I work at IBM Research, and I'm the company's global leader for responsible AI and AI governance. And I'm also the past president of AAAI. And now, today, I would like to welcome you to the AAAI panel discussion on AI agents. Before we get to the discussion on this topic, let me start by saying that, as we all know, AI capabilities and research are undergoing a very fast and significant transformation along many dimensions, including the topics for work, the methodologies, the research community itself, and also the working environment. In this rapidly evolving scenario, it's very important to be able to clearly identify the trajectory of AI and of AI research and the challenges that are still ahead of us to make AI more capable and reliable, but also more safe. So to contribute to this goal, in March 2025, AAAI published a report on the future of AI research, which summarizes the finding of a study of several months of significant AI research trends. The study was led by me as the then current AAAI president, but was conducted together with 25 prominent AI researchers and also supported by a community survey with almost 500 respondents. And the topics that were covered in this study included who is doing AI research, more in corporate, more interdisciplinary, and so on. What new topics is AI research about? Reasoning, factuality, AGI, and many others. How AI research is conducted, evaluation, benchmarking, emerging behavior, and so on, and also covering the geopolitical scenarios around AI. The report can be found on the AAAI website and identified in total 17 topics. And for each of them, you will find a chapter that sketches the history, the current trends, and the open challenges. The report has been intentionally written in a non-technical way because the intent was to reach out to many audiences beyond AI researchers, including experts of other disciplines, policymakers, funding agents in the media, and the general public. We already held in-depth panel discussions on 4 of these 17 topics, and they were AGI, AI perception versus reality, AI reasoning, and AI and sustainability. And today we will discuss another one of these 17 topics, which is AI agents. And AI agents, and as you will see during the discussion, have come a long way in AI, starting from rule-based entities and now evolving in really systems and multi-agent systems powered by a combination of more traditional AI techniques and machine learning and generative AI approaches, such as those in large language models. And this evolution has brought a lot of new opportunities, broader application scope, but also raises some challenges. So during this panel discussion, we will discuss the definition of AI agents, their history, the modern notion of agentic AI, the introduction of LLMs in multi-agent systems, issues of governance, risk mitigation, and possible futures for AI agents. We will do that with 3 panelists. The first one is Atoosa Kasirzadeh, assistant professor at Carnegie Mellon University. Then we have Kartik Talapadula, distinguished architect AI at Oracle, and Michael Woolridge, AAAI president-elect, and Ashal Professor of Foundations of Artificial Intelligence at the University of Oxford. Let me remind everybody that you can write questions in the chat, and hopefully we will have time to respond to a few of them at the end of the panel discussion. So let me start with a natural first question about the definitions of AI agents. And let me address this question first to Atoosa. So there are in the literature many definitions of AI agents at this point. In fact, in a recent paper that you published, titled Characterizing AI Agents for Alignment and Governance, you mentions 7 of them, taken all from the computer science literature. So can you help us understand why there are different definitions of AI agents? What are their main commonalities and differences so that we can better identify what are the main properties of an AI agent?
Thank you. Yeah, as you already mentioned, efforts to understand and characterize AI agents have a long history. If I understand it correctly, the first time the way the term AI agents was used or the term was coined was in a 1977 paper by Feigenbaum called The Art of Artificial Intelligence, Themes and Case Studies of Knowledge Engineering. So since then, obviously, with lots of ups and downs and various different periods of intense attention, the topic of AI agents has been studied by various different researchers in relation to various different architecture, different types of AI systems that were interesting at their own time. So in the 2024, 2025, we observed a surge of interest and attention to the notion of AI agents. And we figured that, unfortunately, lots of researchers are treating this notion as if it's like a topic that came out since we are having large language model agents. Now, understanding the characterization and definition of this term is very important, because when we want to govern or talk about the governance of AI agents, we need to have an operational definition of what these systems are. So we did like a very significant kind of like survey and literature review of the work on AI agents, and we figured that there are various different definitions. Different researchers, according to the leading definitions, index on specific aspects of agency, but there are four main kind of dimensions that are core to definitions of AI agency or AI agents. And those are the autonomy of AI agents, the efficacy, the causal impacts of the systems on the environment, the complexity of the goals that they execute. For example, some of these systems are capable of long-term planning, some of them are not capable of that, and also the level of generality at which they are kind of like executed. Generality is also very important, because if these AI agents have an impact on a very specific domain or sector, then we should talk about domain-specific governance. Otherwise, we should talk about like cross-sectional governance. So efficacy, autonomy, complexity, generality are very important. But again, we shouldn't think about these notions as binary notions. We shouldn't think that an AI system is autonomous or not. There are various different gradations of these notions and various different ways to measure those gradations. And I'd be happy to talk about them as you like.
Thank you. Mike, Kartik, do you want to add anything?
I just wanted to briefly add that I think the report goes into one of those definitions, I think, Atoosa, that you mentioned, right, which comes more from the history of multi-agent systems and how those were defined and so on. But there is at least definitely in the industry, there is also the competing, I guess, or maybe cooperative definition of RL-based agents, right? So the definition of an agent as something that essentially, I think it boils down to two things. An agent is something that can take actions in the world, right? And that can accept observations from that world. And so it changes its behavior to take into account the observations that come in from that world. I don't actually think they're competing. I think that both the views work together in some sense. But certainly, I think today what we're seeing with a lot of the agentic frameworks and the LLM-based paradigm of agents and so on, it relies a lot on this observation action paradigm. And I think that's important to remember as well.
Thank you. Michael?
Yeah, well, I could say a little bit about maybe about the history of agents and multi-agent systems. And it's really fascinating, Atoosa, to see your work and to see how those ideas are interpreted in the modern world. Where did these ideas come from? So they really crystallized at the end of the 1980s and the beginning of the 1990s. And it came from a number of different directions. So I can talk, for example, about my own story. And my own story is that in 1987, I spent an internship working for an organization that ran the UK branch of the internet. And it was in the time in the UK, it was called Janet. And there was a very small number of universities connected to the UK branch of the internet. And I did an internship, and I had no experience with computer networks before. And at the end of that internship, I absolutely understood that networks were going to be the future. And at the same time, we were in the middle of the expert systems boom in AI, and I became fascinated by AI, and I knew that I wanted to do that. And it dawned on me that if the future of computing was going to be networked, then surely the future of AI was going to be networked as well. And so I started to ask myself, well, what happens if we have multiple AI systems talking to one another? How are they going to talk to one another? What languages are they going to use? What are the protocols for that going to look like? How is one AI program, and we quickly latched on the term agent for that, how is it going to structure its conversation? And then another interesting dimension to that was, well, what if my AI program, for example, is not necessarily honest? Or if your AI program is not necessarily honest, how do we deal with that? Or if these two AI programs that are interacting with one another, what happens if they don't share common goals? And at the same time, there were a number of different ideas that were floating in AI. And one really big one and a really important part of that story of agents is the following. The historical approach to AI had been a decomposition of intelligence into its component parts. So learning, planning, problem solving, natural language understanding, and vision. And the observation was made by a number of people at the time that, the field had split into these different areas. How do you assemble those components into an integrated architecture? And that integrated architecture became known as what is an agent. And so the idea was an agent that would integrate all those components of intelligence, not just do one isolated thing, but would bring them all together. Then there were other ideas as well that were floating around. There were AI programs were being used in the end of the 1980s for distributed control scenarios. So where you had two AI programs controlling different elements of a system. And again, the ideas people began to ask, well, what is actually going on here? And those ideas sort of morphed into the idea of agents. So all these ideas came together. And by the early 90s, they crystallized into what you could call the standard model of agents. And the standard model of agents very much had this idea of independent problem solvers that were typically working on behalf of a user or owner or principal. A key idea that they would be interacting with other agents, which didn't necessarily share common goals. And the big questions of the time were, what is the software architecture for one of these things? And how are these agents going to interact with one another? And that, by the middle of the 1990s, that had launched the multi-agent systems community. And that community went on to explore, and still does explore, issues like, well, what are those protocols for cooperation, coordination, negotiation? What are the languages that agents are going to use? And that work is still ongoing. But the really fascinating thing about what we see now is the rise of LLMs has just given a completely new twist to that story and a new set of capabilities. So, for example, when I was busy designing communication languages for agents, never entered my head we'd just be able to do it in natural language. That just seemed a completely fanciful idea. And now we can do that. And so many of the issues that we were dealing with, we've just leapfrogged over. And so this is a really exciting time for this very old idea.
Yeah, thank you, Mike. And in fact, at this point, it really, after this long history, but at this point, agentic AI is really a mainstream area of research and deployment also. In fact, many, including, you may have seen OpenAI CPO declared 2025 as the year of AI agents. In our survey, in our community survey, a majority of respondents found that AI agents are relevant to their research. Many already use AI agents, with LLM being the most common technique, like 29%. And the survey also showed many application areas that the respondents are aware of, such as collaborative problem solving for 68%, distributed decision-making, 54%, as well as social simulation, 41%. So let's start by analyzing what is new now, and for now on the positive side. So Kartik, let's look at the positive implication of introduction of LLMs in multi-agent systems. Are there things, and what are these things that we can do now that we could not do in earlier version of multi-agent systems?
Yeah, I think there is, I want to acknowledge, Francesca, as you're saying, there has been a tremendous amount of interest, certainly, within the industry in adopting these modern avatar of AI agents, which is the LLM-based, LLM-backed version of AI agents. And I say interest because interest doesn't always translate into adoption. And I think that's where we are now in 2025 and probably in the future as well. I think a lot of this is going to hinge on whether all of this interest translates into adoption and deployment in real world, of some of these agentic systems and so forth. But certainly, I think from a research perspective, one of the key problems that LLMs help us overcome is I guess what I would basically call the domain definition curse, right? So my background, my research background, some of you know, is from AI planning. And one of the big problems we've always had in the field of planning, which is as old as, AI itself, has been that you need somebody to come in and give you the expert information. You need somebody to define the domain information for a given application domain, right? And I think in fact, if people on this call who read the report actually touches upon this as well, right? The chapter on AI agents, that one of the big problems with widespread adoption of AI back in the 90s and the 2000s and so on was exactly this, that there weren't enough real world applications. And I think, again, that was because of this bottleneck, this domain definition curse. I think LLMs today, just because of the amount of data that they've been trained on, the size, the number of parameters and what they're able to retain and generate, they act as very good broad candidate generators, right? So regardless of domain, if you go to an LLM, so in fact, I think this is what Mike was referencing as well, that you can now program in natural language, for example. This is not something that you used to be able to do. And you can basically take any application domain, what have you, transportation, logistics, anything out there. And LLMs will give you a reasonably good first pass at things, right? And so in some sense, they are very good candidate generators. Now, is that enough to actually have working real world solutions? No, obviously. And I think, in fact, some of the past iterations of this panel have talked about the need to verify what is produced by LLMs. That's the other important step, right? Once you have a set of candidates, you need to whittle down those set of candidates. You need to verify which ones are correct. Sometimes you might need to optimize, right? Because some might be more correct than the others and so forth. But I think that is one of the really positive implications of LLMs that we didn't really have access to in the earlier decades of AI research and development and so on, that you always had to have a human or a set of expert humans in the loop defining the domain model of, let's say, a transportation domain, an airline domain, an insurance domain, and so on. I think LLMs do a lot of that work now much faster and for much cheaper. And I think that's one of the big positive implications.
Yeah, thank you. Atoosa, do you want to say something more about these positive implications?
Yeah, I think some of the positive implications could be also in the field of like science. So I've been studying a particular type of AI systems known as autonomous AI scientist systems, and these systems are all by definition in the LLM kind of like space, multi-agent systems. We don't call them multi-agent systems, but under the hood, they're actually a bunch of like multiple AI agents that are supposed to automate various stages of scientific progress. And they also definitely pose a lot of possible opportunities for making significant advances in sciences. So I know, for example, a Japanese scientist is trying to use this multi-agentic AI systems in order to study various different genomes or like human genomes or gene sequences that have not been studied before. So he thinks that there are almost 70% of human genomes that haven't been like very well studied. And if we like figure out interesting scientific knowledge by studying them in an autonomous way, then maybe we can make significant progresses in drug discovery and improving human condition, etc. So this could be like one potential positive use case of these multi-agentic AI systems. And because, again, they're working in the natural environment space, obviously many more people, many more types of scientists also can use these types of systems. I'd be happy to talk about the risk of them, because I don't want to say these systems are in an unconstrained way promising, but this could be one really interesting area for positive impact.
Okay, thank you. Michael, anything to add to the positive implications of using LLMs inside a
Well, I think one challenge which remains unchanged and unsolved is something that was that was subject of a great deal of attention, was the issue of sharing meaning. Natural language interfaces bias an awful lot. I mean, I say it's very hard for me to think back to the point where we were designing incredibly crude languages for agents to communicate, and then all of a sudden we can just do it in natural language. So that's great, but natural language is notoriously sloppy And the way that we used to think about solving those problems was ontologies. And we would have very rigorously designed ontologies which formally specify meaning of the terms that agents are going to use. And those ontologies have gone on to be very, very successful and one of the very widely applied symbolic AI technologies. But they were designed for symbolic AI. They weren't designed for the new era of LLMs. But that problem remains. So if my agent is talking to your agent, how do we really know that actually the terms that they're using share a common meaning? My concern is that this is going to turn out to be really quite a big challenge, particularly when we have agents that operate across organizations. Not so much an issue when you have agents that are operating within an organization and we know that they've been designed in the same way, in the same way, using the same training data and so on. But I think it really does become an issue across organizations. Can we use ontologies for that? Maybe there is some work on doing that. I don't know. But this, I think, is actually ought to be fairly prominent on our research agenda. How do we know we're really talking about the same things?
Right. And there are other issues that we'll now maybe consider in having, agents that are built by different entities and that or maybe they are on the web available and then an agent goes and finds it. And so the open-endedness of these multi-agent systems, I think, is something new. And that raises also the challenge. So now we already passed to the challenges and risk part. So let me start with Atoosa. So again, we asked in the community survey about the risks of multi-agent agentic AI systems. And the risks that were mentioned by the survey respondents include misalignment between the LLM's general knowledge and the needs of specific systems, about 60%, they said that. The lack of interpretability, around, again, 60%, and the security risks, around 51%. So what are more generally these risks of an LLM-based AI agents? Some of them, as Michael mentioned, were maybe already considered as challenges and risk in the previous versions of agent systems, but some of them maybe are amplified or introduced by the use of these LLMs. So, and maybe Atoosa, you say, can the properties of an AI agents, these 4 properties that you mentioned, help us also identify the new or amplified risks?
Right. Thank you. Yeah. So as Michael already mentioned, we already know that there's been like a lot of challenges associated with LLMs, just the LLMs themselves or the multimodal variants. And we've made a lot of progress in addressing some of those risks and challenges, but we have not solved those risks like completely. Like, for example, we've made progress in interpretability. We have various different frameworks, various different ways to make sure that we understand what is going under the hood of various different deep neural networks or transformers, etc. But there is no one framework that everyone agrees on. These are all work in progresses. Now, when we build autonomous AI scientists, or like, let's say, autonomous AI agents, most of these AI agents are supposed to be autonomous, we want different conflicting things from the systems. We want them to be very safe, to do exactly what we want, but also they want them to create like new creative knowledge that humans aren't able to like really create or produce. So in short, then the types of systems that we are developing is becoming much more complex. And the types of communication issues that, very importantly, Michael mentioned, that existed between different agents I think scales up because there's also communication issues between humans and different agents. And sometimes we are not, even as humans, we are not able to perfectly clarify in a natural language way, like what are the requirements that we have from the systems. So there's this very hard, like interpretive communication challenge between the way we express things in natural language, the way the model understands those natural languages, the way the mathematics constrains various different understandings of the model. And I think that is an unresolved problem. When we have multi-agent systems, in addition to all the other risks that you mentioned, I think there are 3 specific types of risks that surface that don't exist maybe when we have just one AI agent system. And there's a report that was published this year. It's called Risk from Advanced Multi-Agent AI Systems. And in that report, we, in collaboration with lots of colleagues, we explain this. But very briefly, there are three specific types of risk of harm that could arise from multi-agent AI risk systems. One is the risk of miscooperation. So we are not sure if we can guarantee that the systems cooperate well with one another. It could be that each system in its isolation is performing its task quite well, but then for all of them to come together and perform this holistic task, they can just fail. The second problem is the issue of conflict of interest. So various different systems are supposed to perform tasks again on themselves, like correctly, but then there's an issue of optimization, multi-objective optimization that has been around since like hundreds of years ago. And that is a problem where, for example, you want to make sure that the system is producing like helpful results, but also the results are harmless. And you can't have a system that always optimizes perfectly globally for these two systems, for these two values. So obviously we can imagine that in a multi-agentic systems, we have, let's say, an AI agent that is supposed to run an experiment, and an AI agent that is supposed to produce like perfectly clear papers that can be understood by a variety of researchers. And so then there's going to be the choice of simplicity when the agents wants to report the results of the experiments, and the choice of like complexity when the system wants to run the experiments. And the question is, how would the system decide about the right level of trade-off and the right level of value conflict resolution? So miscooperation, conflict, and the third type of risk is the risk of collusion. And so this is when again different systems want to optimize for various different targets, but they values their targets collide with one another. And again, these are specific risks that don't arise when we study a specific agent in its isolation, but when we put the systems together, new types of risk emerges.
Yeah, Karti, do you have anything to add to the challenges, additional challenges and risks?
Yeah, I'll just say that I think a lot of the issues that Atoosa raised are very pertinent issues. I don't know, just being pragmatic, right? I don't know that we are ever going to solve all of these issues in some sense, because the way that especially adoption of AI agents is proceeding, it's less about a unified frontier kind of advancing, which is usually how we kind of look at it from a research perspective. But in industry, like in the adoption of these things, certain narrow things tend to become more important than other ones, for example. So to take the example of one thing that Atoosa was saying, the rule following, right? That is important right now. Like people who are putting these agents into real world systems, they absolutely want them to be able to follow rules, and they're trying to do everything they can, including prompting, guardrails, fine-tuning models that these agents are implemented on, to make them very restricted in a specific use case. But I agree, I think there are a lot of these issues, because the fundamental problem, or maybe not a problem, but the fundamental issue is that we are trying to get these agents to replace human behaviors and to replicate human-like behaviors. And of course, humans, I think, are much more complex than any agent that we can create. So I think that's really the key thing there.
Yeah, thank you. And I think that, yes, what Atoosa mentioned also, this fact that you may try to reduce or mitigate the risk of a single agent, but then when you put them together, you get this, additional risk. For example, another one is related to the issue of data privacy, because data is shared among these different agents, tools. They're not necessarily all agents, in the components. And so how are you going to handle, or do you need to modify the way you handle this data governance or data privacy issue, because now you have this data shared with components that you didn't even build, somebody else builds, and you don't even know the security aspects of the privacy aspects and the properties of that component. So is there anything else, Mike, to add around the new challenges that are posed
I
by
think There's one key one which I think is really, really important, which is a really new area, I think, in AI generally, and it's the issue of security. I mean, if we are using LLM agents and the way that we're getting to do the things is by providing them with prompts, then we immediately open ourselves up to vulnerabilities like prompt injection attacks. And at the moment, it really seems like we don't have deep fixes for those problems. There's a game right now between those that are figuring out how to attack these models and those that are trying to develop guardrails to defend against them. And it's a game of cat and mouse. And I say we are at the moment not in sight of any really, really deep fixes. And that becomes worrying if we're going to have agents that really go out and do things for us. I mean, I'm going to be concerned if I hand over my credit card number to an agent and that agent then gets hacked. So this, I think, has to be on the agenda. And it's kind of weird. I mean, Francesco, we remember AI from 25 years ago. Security like this was not something I think that we envisaged as an issue at all. We didn't realize that this was going to be a challenge in the way that it is now. And I can remember, when I first saw the first crude prompt injection attacks on these models, and it began to dawn on me, this is going to be a problem. And it still is a problem. And despite all the effort that we've seen go in from the world's richest companies over the last 5-6 years into trying to defend these models, you don't need a PhD in AI to get around those guardrails. So this, I think, is going to be a big challenge, and it may be one of the make or break issues for the technology.
So, Michael, that's related to the input, the prompt that you give to an agent based on an LLM. But then there are also challenges on the output side, because the LLM can hallucinate, which means that if you give the LLM the task to call another agent or another tool, then the LLM could call the wrong agent, or they call the agent with the wrong parameters, or so that is also in the output side, where you may have calling something that is not what is needed for the task to be accomplished. So that's really using natural language as all this domain specificity that is given for free in some sense. But then you also have all these other additional challenges because of the vagueness and the possible vagueness of natural language, but also possible hallucinations and the prompt injection and the robustness, security issues, and so on. But then, I mean, when we go from so we said what LLM can bring in positive or negative terms to an agentic, a multi-agent systems. But then what can agentic system can bring to LLM? So for example, can the fact that you put together multiple components help mitigate these risks with LLMs, like hallucination, non-determinism, reliability, trust? So yes, LLMs have these issues, but maybe putting together other pieces in a multi-agent system can actually help us address those issues. What do you think, Kartik?
Yeah, so I agree. I think so. So I want to go back a little bit to, again, couple of decades, maybe 30 years back in AI, where, if you guys remember, cognitive architectures were a big thing at that time, right? So we had all these things like SOAR and a bunch of other architectures, and the idea there essentially was that an AI system is not a single model or a single component, but it is a combination of many different components. And in fact, even today in the textbooks that all of us learn AI from and so on, if you look at the prototypical AI system picture or the AI agent picture, there are many different components. Some are responsible for the vision, some are and perception, some are responsible for the actuation, some are responsible for the processing and the planning and the thinking and all kinds of other things. And so the idea was that you would need a cognitive architecture to basically combine all of these different components and to enable intelligent behavior, emergent intelligent behavior. And I think, again, the historical basis for that is that it comes from trying to implement robotic agents. The SRI had the Shaky, the robot, and Strips, and all of those things that came out of that. Now, I do think that there's something we can learn from that. So a couple of things I want to talk about. One is this whole notion of open versus closed worlds, right? So in the past, when we had more, let's say, deterministic AI systems, for lack of a better term, and also just deterministic programs, they were essentially executing on a closed world. Whereas today, I think one of the problems with LLMs is that we are essentially in an entirely open world. You don't even know, for example, if you will get the same output from an LLM twice, even if you give it essentially the same inputs and so forth. And again, a lot of it is a black box, right? We don't really know what's going to come out the other side of that black box. So one of the emergent trends that I've seen, at least certainly in the industry, is LLMs are useful to deal with completely open worlds and open scenarios. They are good candidate generators. We discussed this. But once an LLM actually produces an output which you have verified or validated in some way, you should close off that portion of the world, right? So you start with a completely open world, and then you close small sections off of that open world, because you say that, okay, this is an acceptable solution. It's above a certain threshold, or this is a verifiably correct solution because I verified it with some external thing, right? And then the important thing, the key thing, is to not revisit that closed portion of the world anymore, right? You can still use your agentic, your LLM-based agentic system on the remaining open parts of the world, but it's essentially a problem of how do you close off portions of the world, and I think that also will deal with all these issues of uncertainty and inconsistency with respect to LLM chains. It will and agent chains. I think it will also deal with this issue of error propagation, right? Because right now, when we have especially agentic chains, when you have multiple agents that are part of a workflow, and if earlier on in the chain you have some error that creeps in, that's just going to keep getting propagated down that chain. So I do think that we can take inspiration from the cognitive architectures of the past, where we can kind of wall off almost certain specific areas, and then we can say, in order to close off this section, I need an output that exceeds the following threshold, right? Again, we're in the world of now probabilities and continuities, right? It's no longer a discrete world of 0, 1, and this is absolutely correct versus absolutely incorrect. So I do think that, and I see a little bit of this happening certainly in the industry right now, where one of the ways that people have found to mitigate some of the problems with LLM-based agents is precisely to embed them in these workflows. Of course, there's also a lot of rediscovery going on in some sense, right? Of a lot of concepts that were
We'll talk about.
explored and published 30 years ago or 40 years ago. But again, that's part of the challenge.
So, but this is important point that you make. But I think that a basic point that you also make is that over time, with LLMs, in some sense, people thought that you could forget about multi-component architecture. You could embed everything inside a single model. Oh, no, we don't need to have this and that and that, and then deal with the communication and the sharing interaction. Everything is, you just give me all the information. I train a single model, and then the model can do everything, can do planning, can do reasoning, can do this, can do that. So I don't need anything else, just one piece. And now we are rediscovering instead, I think, with this idea of agentic AI, coming up, we are rediscovering that we need, yes, LLMs can do a lot, but not everything. And you need all these other pieces to get the right reliability, the right security, the right, properties that you want. Right?
And just briefly, at the risk of saying something controversial, because what fun is a panel if somebody doesn't say something controversial? The modern AI provider companies, right? We all know who they are. They are kind of almost, it's almost they're finding very inventive ways of saying exactly what we're saying here, that one model is not enough, we need multiple models and so on, right? So for some of them, it's an efficiency play. Oh, we don't want to send every prompt to like a 100 billion parameter model, we need smaller models to do this. For some of them, it's a context play, right? Oh, we can't send the entire context, append everything and send it in one prompt, so we want to break it down and so on. But this is it's the equivalent of kind of going around your head to touch your nose, right? That's not the fundamental issue. The fundamental issue is what you had pointed out, Francesca, which we've been discussing, which is that one model is not going to be sufficient to solve all of these issues, right? You do need fundamentally different components, and you need them to interact with each other. They can all be agents, right? But you need a way to coordinate all of that. So yeah, I agree.
Okay, anything else to add on this topic?
Yeah, just that's fascinating. I mean, I'm learning things and giving new ways of thinking. Thank you, Kartik. It's really interesting. Just to throw in related to that, I mean, I think it's really quite fascinating that we have research which says that LLMs perform well when they play roles. And that fits again so well into the traditional view of multi-agent systems, that you have a number of agents playing very specific roles. And also, I think, Francesca, the problem of can you use a multi-agent architecture to try to overcome like properties of hallucinations? Very natural to think about a collection of agents that are in some kind of dialogue where they are challenging one another and demanding an exhaustive proof, just almost like sort of chain of thought, but with kind of multi-agent approaches. And a really interesting thing, I think we're at the very beginning of that journey with LLM agents to understand the ways of structuring them. But it's really amazing to see these ideas unfold.
Yeah, so Atoosa, so now that we have this picture now of these multi-agent systems, including LLMs and so on, so how can we use our knowledge over many decades of AI agents to define the governance, the right governance of these systems? And does the right governance depend on the properties of the specific agent profiles, like you mentioned earlier?
Thank you. Yeah. I think I want to start again from the place that, from the observation that the governance of LLMs, just one model, has been like very complex. Now we are moving to this very complex, like a much more complex kind of space. What should we do? I think one approach to take is like, oh, we can't resolve this problem, so like let's just like pick and choose and go forward. I'm kind of against that approach. I think we can actually develop some structured ways of thinking about the governance. And I want to go back to the characterization of AI agents across these 4 dimensions, like the dimensions being autonomy, causal impact, generality, and goal complexity. And so the idea is like, okay, if we want to develop an AI agent in a particular domain or in relation to a particular deployment area, which dimensions we actually really want to govern? And if we ask this question, then we would be able to make at least some progress in relation to the governance space. So for example, it could be that we have some AI agents that are like that are performing fully autonomous actions. Like think about Waymo. Like Waymo is an example of an embodied multi-agent AI systems, according to some people. So for that particular system, we are thinking about the deployment environment. There are specific rules, principles developed for transportation, like legal domains, like different jurisdictions have different standards, etc. And we have seen from IEEE and various different other professional domains that specific standards have been developed around the governance of this particular type of AI agents. But Waymos, I mean, they perform complex tasks, but they're also not like reasoning or planning about like the future conversations with like an adult or something, or maybe they do, or maybe with a child or something, or maybe they do. But if you think about like multi-agentic AI companions that are going to be these autonomous systems that can figure out what a specific child or kid or adult wants to do, seems like now we are in a realm where actually the goal complexity, the complexities of tasks that the system is performing are also become very important. Then we need to break down the governance questions across this particular dimension of complexity, and then think about like the governance in this like more hierarchical way. In the case of like like companions, AI companions, again, seems like the systems are able to have conversations across a generality of different kinds of domains. Then we need to figure out, okay, how we have to consider various different standards. Like I read, I think it was yesterday or today, that a report was published by OpenAI, basically giving kind of an statistics about what percentage of the users maybe are having suicidal conversations, talks with the chatbots that might induce suicidal thinking and etc. And they're now having conversations with hundreds of psychologists and psychiatrists and etc. And so I think this example shows cases where first of all, it shows governance is very hard. Second, it shows governance requires knowledge of various different disciplines, and we have those disciplines. But to govern this very complex AI agents, we just need to bridge and bring in those knowledges as much as possible and create new spaces for governance.
Yeah, thank you. So, Kartik, in a recent talk that you gave, you explained that a lot of work around risk mitigation, governance, and so on, and solutions for various issues in multi-agent systems. And much of this today's work on agentic AI system is built on top of work done in the 70s, 80s, and 90s. So do you think that this is something that is widely known by people building agentic AI system, or is there the risk that researchers, and more than researchers, companies working and deploying agentic AI kind of reinvent the wheel in the sense of not being aware of the many ways of addressing the issues and studying the issues in the past and the solutions that have been devised? So with the use of LLM, do we need to start from scratch, rethinking about all this, or we can reuse and adapt some of the existing results?
Yeah, no. So in fact, I should say that I don't. The answer is no. I don't think people are aware of or even reusing or rebuilding on a lot of the prior work and research that has happened in this space, right? The talk that you're referencing, and I'm happy to share it with the audience afterwards. I was trying to personally make a point, right? That a lot of what we see today, and so the talk was specifically about today's agentic frameworks, right? So think of things like AutoGen, Crew AI, LangGraph, all of these modern systems that people have adopted quite widely in order to design these chains of agents, agentic systems, and to evaluate them and so on and so forth, to deploy them for wide use and so forth. And the point that I was trying to make was that a lot of the protocols that these frameworks are inventing are really reinventions of things that have been around, for decades at this point. I mean, again, the point is not that the protocols were around and that somehow you should cite them. It's not an academic argument that I'm making, right? But rather that we should build on top of it rather than reinvent it from scratch, right? That's just the more efficient way to do it. So to give you like a couple of examples on this, right? And I'll go back to something that Mike said about, the the inherent ambiguity of natural language, right? We all know this. Like this is why we love, our languages. English, famously so, right, is a very ambiguous language. You have no clue what somebody is trying to say in English, and in fact, we have all these different dialects and accents and so on. Speech act theory, right? This is from Austin and Searle. This is from like the 60s and so on. Speech act theory has been around for a long time, right? And so, in fact, I see Mike nodding along. A lot of the basis of today's modern theory of multi-agent systems kind of is grounded from that notion of speech act theory and like the philosophy of how agents would even communicate with each other, first of all, right? How would they interchange information? How would they communicate with each other and so on? And then, of course, Ray Perot and Cohen and others came up with like plan-based philosophies for agent communication and so on. This is all, stuff from the 60s and 70s that I'm talking about. Now, why is this stuff important? It's important because today we see providers reinventing a lot of these things. So for example, AutoGen has this notion of a group chat manager, right? What does the group chat manager do? The group chat manager is basically a component that takes all of the verbose output that is generated by the different LLM based agents, right? And it tries to coordinate that group. It tries to coordinate that team essentially, right? To try to push them towards a common goal, towards a common resolution and so on. But again, the group chat manager is basically the equivalent to the communication facilitator in something called KQML. So there was this whole, interoperability platform called the Knowledge Management Language, KQML, right? You can look it up. So that has existed. Similarly, Crew AI, they work under this notion of, agentic crews, right? Groups of agents and so forth. That again builds on something called the contract net protocol, which existed, 30 years ago and so on, right? So a lot of this, there's been work in the multi-agent systems communities in general, the AI community. And I think it's important for us to be cognizant of a lot of that work that's happened, if for nothing else, then to not reinvent the wheel again, right? And to look at some of the pitfalls of all of these things and so on. What I'm mentioning is a subset, but increasingly, 2025, 2026, it may be the year of the agent, it may not be. But what is going to be important is we need to have a little bit of standardization at least of how these agents are communicating with each other, right? Maybe we don't go to the extent of having entire ontologies and so on and so forth, right? But we do need protocols. Like I think one the key takeaways, if I had to say, 2 or 3 key takeaways from the research that I did on this, one, communication is action, especially in today's world of agents and LLMs and so on. Communication is action. Design protocols, not just prompts, right? We need ways for these agents to kind of interchange information, metadata, all kinds of things, right? And the third, orchestration is essential. You have to plan for orchestration and so forth. But anyway, let me stop there. I think that's part of the lessons from that.
Thanks, Karthik. Mike, go ahead.
Yeah, I can't tell you how pleased I am that we're talking about speech acts and how fundamental that was. And I realize a lot of listeners won't have been exposed to the idea of speech acts because it hasn't been fashionable in AI for a while, frankly. But the idea of speech acts is that when we as human beings, when we say something, we do that typically with some particular goal in mind. So when I ask my wife to make me a cup of tea, I mean, my goal is that she will take on board the intention to make me a cup of tea. And the work that Karthik referred to there, which is beautiful, very insightful work, was trying to understand how we can make precise the various different kinds of speech acts that we all use so that they could be used by AI systems to plan how to carry out dialogues. And it was very influential early work. And one of the really remarkable things for me now is LLMs do speech acts. So can we, if I'd love to be a PhD student now with all of these problems in front of me. Can we try to understand the speech acts that LLMs provide? And I think, Karthik, your point about protocols and focusing on those, I think I absolutely buy into. That is absolutely where our activity should be. And I just emphasize again this idea of it really does seem like LLMs perform well when they're playing roles, which ties into this idea very, very neatly. But there is an entire theory. I mean, speech acts is one component of the theory of pragmatics in linguistics that was, as you say, was invented by, I mean, it goes back as far as Wittgenstein and the idea that Wittgenstein had of language games. And then you mentioned Austin and Searle, who passed away recently, but many others like Grice, for example, incredibly influential thinkers about those. And they were really trying to understand the nature of human dialogue. And can we apply those ideas to understanding, what large language models do? I mean, I'd love to be a PhD student addressing those problems now because they'd be such cool problems to look at.
Yeah. Atoosa, do you want to add anything?
Yes, I love this conversation because like when I started looking at the problem of LLM alignment in 2020, I just thought, look, this is a sort of a conversation between an artificial creation and humans. And so why researchers who are developing the systems don't rely on speech act theory? It's so shocking. And I just want to, again, as Karthik said, highlight that for some reasons, maybe various different reasons, lots of more recent AI researchers, and of course not all of them, have become so ahistorical. So it's as if nothing existed, as if no discipline has reflected on ideas of good communication, meaningful communication, actually whether LLMs should be able to produce speech acts, what types of speech acts are there. Maybe LLMs should not output performative speech acts, for example, if they are having conversation with children, things like that. So like really trying to think about these systems in a much more theoretical, philosophical way, rather than just trying to measure something about them that is not rooted in any kinds of like conceptual work, wouldn't maybe make us or bring us significant advances as we wanted. So yeah, this idea of like pragmatism that is coming from philosophy, role-playing, speech acts, communication theory, I just want to give a shout out that those ideas were very important for alignment of LLMs, very important for building successful multi-agent systems as well.
Yes, and in some sense, I think that the fact that these LLMs are trained over text that covers every discipline, covers everything, in some sense, maybe I think makes people think that if there is something to learn from other disciplines, it's there. And the LLM will have learned it in the training, no? So in some sense that reduces, it makes people perceive as if it's less needed to go and look at other disciplines and what they can bring to improving AI, to improving this machinery that we embed into machines, because in some sense the embedding of cultures, knowledge over all the disciplines is already there, in the training data. So yeah, it's also true that the speed and the amount of papers and results and announcements is so overwhelming and so fast that people they're so overwhelmed by this what's happening every day, then maybe they have less time and going and look at all the things that have been done in the past that can be useful if adapted, to the current scenario. So the overwhelming amount of information, I think it's also an impediment to this need for exploration and need for looking back at what was done earlier. So let's finish with some final thoughts from all of you about the future of agentic AI systems. So now we looked at the opportunities, we looked at the risks, the challenges, we looked at the past, the present. So, but are you optimistic, pessimistic? What do you think the future of AI agents is at this point? Yeah, Mike, go ahead.
So I think, firstly, there is a lot of snake oil being sold out there, with really some really trivial and uninteresting work being sold as agents. But I think there are some deep applications. Like the one that I really loved was I think it was DeepMind work on the AI co-scientist, where an assistant in a scientific problem was organized as a collection of agents, each playing a role, exactly as we talked about earlier. So I think there is real work there. I think what we're going to see is a spectrum of agents, from agents that are kind of agents like customer service agents, right through to those applications like the DeepMind one. And I think the really interesting for me sort of scientific challenges and the excitement for me is at the top end of that spectrum, but there is going to be a huge amount of benefit to be obtained by building agents across that spread of that spectrum. And I think the last thing I'd say is, as I say, right back as far as the 1980s, I got the idea of agents. It seemed to me to be a natural development of ideas in AI. It just seems to be just as relevant today.
Thank you. Atoosa?
Yeah, I think it's very important to kind of try to play around with some of this, like the most advanced versions of these multi-agentic AI systems in particular domains, and figure out their limitations and their opportunities. So for me, one of the very interesting areas is, again, looking at the instances of autonomous AI scientist systems, which is actually a type of systems that people have started looking at since like last year in the context of like LLM agents, and they're trying to figure out where and how these systems fail, and whether there is always a necessity for having like expert humans or careful humans like in the loop or not. And I think just playing around with the particular types of systems and trying to look at the risk and benefits would really help us to make advances in the field of multi-agent AI systems the next couple of years.
Thank you, Atoosa. Karthik, final words?
Yes, I'll be brief. I know we're almost out of time. Couple of things that I think we need to fix in order to get AI agents actually, again, like I said, to go from interest towards adoption, right? One is this notion of like role-based access control. We mentioned this a little bit, but if you want agents to engage in fundamentally complex behavior that humans have shown, you need to also give them that filter that they will not expose certain kinds of data or certain kinds of information, depending on the audience, depending on the control. So that's one. The second is in terms of the cost, right? So the cost of running these agents today is prohibitive, right? And I think that can be tempered down quite a bit, right? Also, because a lot of things that we are using agents for today, it's just wasteful. You don't need to call an agent for a deterministic flow. Once it's established, you can just execute that deterministic flow on a CPU. You don't need to call an agent that's running in a data center in, Nevada somewhere, right? So that's the second thing. I think cost is, and when I say cost, I mean, electricity, water, environmental considerations, all of those things rolled in, right? That's the other thing. And I'll end with this. I do think that AI agents and agentic workflows, they have a lot of potential to greatly increase the productivity of humanity at scale, right? We just need to direct it toward the problems that matter, right? As Mike said, we need to kind of be able to separate the snake oil, which there is a lot of right now in the industry, from the really important problems. Today, the problems that we are gated by unavailability of expertise or enough humans to do something and so on. If we can apply agents towards that, I think we can see a great productivity boost. Whether we'll be able to do it is the big question.
Thank you, Karthik. So I'm sorry that we didn't have time to go through some of the questions from the audience, but I checked some of the comments, and I think we covered some of the issues and some of the topics that they were mentioning. So let me finish by thanking all the panelists for a very insightful discussion where I learned a lot. I hope you all also have learned, and given also some good food for thoughts on AI agents. So thank you also to all of you that are here joining us. The panel has been recorded, and the recording will be available soon on the AAAI website, the same website where you find the Future of AI Research report, and you can also find the recording of the previous panels. And it will also be available soon on the AAAI YouTube channel. So thank you all, and see you soon for another interesting discussion on AI. Bye-bye.